Section 6.1. We have three objectives to maintain with this section. First objective is how to find a point estimate and a margin of error. Second objective is how to construct and interpret confidence intervals for the population mean, which is sigma, is known, and how to determine the minimum sample size required when estimating a population mean. So the first objective is point estimate for population mean. So the population mean. Point estimate. A single value estimate for a population parameter. The most unbiased point estimate of the population mean mu is the sample mean x bar. So this information might show up on the homework as a knowledge check. So estimate population parameter mean, which is mu, with sample statistics x bar. So the most unbiased point estimate of the population mean mu is the sample mean x bar. Here's an example. According to this question, a researcher is collecting data about a college athletic conference and its student athletes. A random sample of 40 students is selected, and their number of hours spent on required activities for 1 week are recorded. Question is, find a point estimate for the population mean m, the mean number of hours spent on required athletic activities by all students in the conference. So this is just a sample. 40 students are randomly selected, and we have the data for 40 students, and our job is find a point estimate for the population mean, not the sample mean, the population mean. So the answer to this question is, the sample mean, we're going to find the sample mean of the data, which is the sum of all those data entries divided by how many entries we have. So on the previous slide, if you add all those minutes and divide them by 40 samples, this is the sample mean. So the point estimate for the mean number of hours spent on required activities by all students in the conference is about the same thing as x bar, the sample mean, 19.9 hours. So this is the most unbiased point estimate. Next, we're going to look at the interval estimate. Interval estimate, an interval or range of values used to estimate a population parameter. Before finding a margin of error for an interval estimate, first determine how confident you need to be that your interval estimate contains the population mean mu. So again, we talked about point estimates. Now we're taking a look at interval estimate. It's an interval or range of values. It's used to estimate a population parameter. So we're still going to estimate a population parameter, but just using x bar. This time we're using an interval or range of values. This is such an important vocabulary, level of confidence, which is going to show up in the problems. Level of confidence C, the probability that the interval estimate contains the population parameter, assuming that the estimation process is repeated a large number of times. Then we have the critical values. Critical values are values that separate sample statistics that are probable from the sample statistics that are improbable, probable, or unusual. So when you look at this barrel distribution, Z0 is in the middle, and then this is the Z critical, and then this is the negative Z critical. Knowing this shape is going to help you to solve the problems. And then when you look at this yellow area, how do you calculate this yellow area? So C is this blue area, and then under the curve, we have the number 1. So if you subtract the blue area from the whole area under the curve, which is 1, so 1 minus C, but then each tail is going to get the half of this area, so each tail is going to be 1/2 times 1 minus C. So what this means is for problems, if C is 90%, C equals 0.90 are in blue region. So we have the 90% of confidence interval. So 0.90 are in blue region. And then you will do the 1 minus C. So 1 minus 0.9 is just 1.1. So this will be the total area shared by yellow regions. And then for each yellow region, we're going to divide this by 2, which will be 0.05. And then this will be the area in one tail. And then Negative Z critical is negative 1.645. So we're gonna just find the Z value corresponds to this area. And then positive critical Z value will be 1.645. Critical value separating the right tail. 90% of level of confidence. If the level of confidence is 90%, this means that we are 90% confident that the interval contains the population mean. So this interval contains the population mean with a 90% confidence. And corresponding z-scores are 1.645 and negative 1.645. So every time the question talks about 90%, you can use these z values looking at from the chart. If you just write them down on a piece of paper, because some of the confidence levels are just so popular, 90% confidence interval represents the z-scores of positive and negative 1.645. Sampling error. The difference between the point estimate and the actual population parameter value. So this is sampling error. It is the difference between the point estimate and the actual population parameter value. For mu, the sampling error is the difference between the X bar and the mu. Mu is generally unknown. X bar varies from sample to sample. We're going to take a look at the word margin of error. Margin of error, sometimes it is called the maximum error of estimate or error tolerance. The greatest possible distance between the point estimate and the value of parameter it is estimating, denoted by E. So error, margin of error, E, will be calculated by Z critical times sigma of X bar. And then which can be also translated as Z critical times sigma, if you know the sigma, which is the population standard deviation over square root of n. This will be calculated for margin of error for mu when sigma is known. And we have to pay attention that in order to use this formula, the sample must be a random sample and population is normally distributed, or n must be greater than or equal to 30. Here's an example we're going to look at. It's about finding the margin of error. Use the data in example 1, which was about athletes, and a 95% of confidence level to find the margin of error for the mean number of hours spent on required athletic activities by all students in the conference. Assume that the population standard deviation is 2.4. So this is where the sigma is known. So population standard deviation is given as 2.4. And then we're going to find the margin of error. So with the 95% of confidence interval. Now, here's the solution. Because sigma is known and it's given in the problem as 2.4, the sample is random and n is 40, which is greater than 30. So we can use the formula which was given on the slide for margin of error. And now we need the z-score that corresponds to 95% of confidence level is 1.96. Again, this will be obtained from the z-table. But again, 95%, 90%, they're very famous. 95%, it just gives you 1.96 of the z-score. This implies that 95% of the area under the standard normal curve falls within 1.96 standard deviation away from the mean. 95% of the area will fall within 1.96 standard deviation of the mean. Using the values, 1.96 is the Z critical, sigma is given as 2.4, and n is given as 40. We can calculate the margin of error equals Z critical times sigma over square root of n. So this is the critical Z value, this is the sigma value, and we're going to take the square root of 40. Using a calculator, we can find the margin of error as 0.7, which means you are 95% confident that the margin of error for the population mean is about 0.7 hours. Confidence intervals for the population mean. A C confidence interval for the population mean mu is when you subtract error from the X bar and add the X bar. So this is a C confidence interval for the population mean mu. And then this is where the error will be calculated. The probability that the confidence interval contains mu is C, assuming that the estimation process is repeated a large number of times. Constructing confidence intervals for mu. Finding a confidence interval for population mean when sigma is known. Verify that sigma is known. So here, I'm going to just start the slideshow from this current slide. So finding the confidence interval for a population means verify that sigma is known, sample is random, either the enter the population is normally distributed or n is greater than or equal to S30. And then 2, find the sample statistics n and x bar. So x bar is equal to add all the x values and divide them by n. And then the first one is also either n has to be greater than or equal to 30, or they have to tell you that it is a normally distributed shape. Find the critical value Z critical that corresponds to given level of confidence interval. Use table 4, appendix B. And we need to take a look at how we can find this Z chart, or is there an easier way to find the table 4 and this? Find the margin of error E. The margin of error will be calculated using this formula. Find the left and right endpoints and form the confidence interval. Left endpoint is x bar minus error, margin of error. Right endpoint is x bar plus margin of error. Here's an example. Use the set data in example 1 to construct a 95% confidence interval for the mean number of hours spent on required athletic activities by all students in the conference. And then if you remember, X bar is given 19.9 and error is given 0.7. So we found the error and we found the X bar. So left endpoint is X bar minus E. So we're going to subtract these two values. Right endpoint is we're going to add these two values. And then this will be the interval for population mean mu is going to be between 19.2 and 20.6. And then if you just represent it on a number line, this is 19.2 and 20.6. With 95% confidence, you can say that the population mean, which is the number of hours spent on required athletic activities for the entire population, is between 19.2 and 20.6 hours with a 95% confidence. Constructing a confidence interval, which is 2 of 3, second question. Use the data in example 1 and technology to construct a 99% confidence interval for the mean number of hours spent on required activities by all students in the conference. So we're changing confidence interval from 95% to 99%. The book says Minitab and StatCrunch have features that allow you to construct a confidence interval. You can construct a confidence interval by entering the original data or by using the descriptive statistics. So actually, using the Z table is easier for me. And then they show you how you're going to use the Minitab and StatCrunch. For Minitab, 1 sample hours, descriptive statistics, you're going to enter the values. N is 40, mean is 19.25, standard deviation, mean, and 99% of confidence error. And for StatCrunch, 99% of the confidence interval, and then it gives you these numbers. The third part of the question is, from the displays, a 99% of confidence interval for mu is 18.9 and 20.9. Note that this interval is rounded to the sum number of decimal places as a sample mean. With 99% confidence, you can say that the population mean is between these two numbers. Another question that we're going to look at, it says, A college admissions director wishes to estimate the mean age of all students currently enrolled in a random sample of 20 students. The mean age is found to be 22.9 years. From past studies, the standard deviation is known to be 1.5 years and the population is normally distributed. So we need to pay attention here that the sample size is not 30 or bigger than 30, it's a very small number of 20 students, but because the question says that population is normally distributed, we can use the formulas that they're given. We're going to construct a 90% confidence interval for the population mean age. So we have the sigma norm, mean age is found to be random sample size, standard deviation is 1.5, and construct interval confidence interval is 90%. So n is 20, x bar is given 22.9, sigma is 1.5, and z critical is 1.645, because if you remember the previous examples, 90% of the confidence interval means this critical is 1.645. Margin of error at the 90% confidence level is, we can just calculate, plug in z critical, sigma, and square root of n, and we can find the margin of error. We can find the left endpoint by subtracting the margin of error from x bar, and then right endpoint will be found by adding the margin of error to x bar, and then we're going to create the inequality for mu. So the population mean mu will be between 22.3 and 23.5 with a 90% confidence. Interpreting the results. Mu is a fixed number. It is either in the confidence interval or not. Incorrect. There's a 90% probability that the actual mean is in the interval 22.3 and 23.5. So that's not right. When we use the 90% of confidence interval, that doesn't mean that it's a 90% chance. Correct. If a large number of samples is collected and a confidence interval is created for each sample, approximately 90% of these intervals will contain mean. So the horizontal segments here represents the 90% confidence intervals for different samples of same size. In the long run, 9 of every 10 such intervals will contain mean. Finding a minimum sample size to estimate the mean. Given a C confidence level and a margin of error, the minimum sample size n needed to estimate the population mean mu is n is equal to z critical times sigma over e squared. N is not a real number, then round n up to the next whole number. So n will be always rounded to the next whole number. If sigma is known, you can estimate it using a provided preliminary sample with at least 30 members. Here's an example. Researcher in example 1 wants to estimate the mean number of hours spent on required athletic activities by all students in the conference. How many students must be included in the sample to be 95% confident that sample mean is within 0.5 hour of the population mean? So it's 95% is the 0.95 is the C value. So that gives me the critical value of 1.96. Sigma is 2.4. Error is 0.5. So if in order to calculate the n, we just have to plug in these numbers to the formula, and we're finding the n to be 88.51. Because n is not a whole number, we're going to have to round this to the next whole number, which makes 89. So the researcher needs at least 89 students. The researcher has already 40 students, so you just need 89 minus 4, which is 49 more students. So there's a mistake here. It's going to be 49 more members. Note that 89 is the minimum, so the more is better. And this is all about 6.1.